Hey guys, welcome to your Unit 6 Lesson 1 notes on powers and exponents. By the end of the day, you will be able to use powers in expressions. So let's start out with one of the most basic powers, a perfect square. Yay! So I have examples of perfect squares down here. Here you make I'm making squares of dots. So I've got 1 dot by 1 dot, so you measure like 1 by 1. And 1 times 1 equals 1. Yay. Let's do it again. These are little, oh dearest. These are little ones. Okay, here we've got 2 by 2. 2 times 2 equals 4. Okay, so one perfect square is 1. Another perfect square is 4. We've got another guy over here. We've got 3 by 3. You count out all the dots in here, you'll see that there are 9. So 3 times 3 is 9. Now let's do one more. If I have 4 dots here and 4 dots here, I count them all up and I find out that there are 4 times 4 equals 16 dots. So these numbers that we've listed so far, 1, 4, 9, 16, these are all examples of perfect squares. A perfect square is what happens when you find the product, that is, you multiply. You find the product of a number and itself. So you multiply a number by itself. So 1 times 1 is 1, 2 times 2 is 2, 3 times 3 is 9, 4 times 4 is 16, 5 squared is 25, 6 squared is 36, 7 squared is 49, 8 is 64, 9 squared is 81, 10 squared is 100, 11 squared is 121, 12 squared is 144, and guys, guess what? I could keep going listing these on for literally forever, but I'm not going to. I'm going to run out of space on my page, and I don't need to. For future work, it's nice to be familiar with these so you can recognize them if they come up. And when we deal with perfect squares and we deal with factoring in a bit, but just so you can refer to them, there you go. There's some square numbers. Okay, great. But there's a shortcut way. You don't have to always write, oh, hey, 6 times 6 equals 36. There's a shortcut way to writing out all those times 6s, and that's with the use of an exponent. An exponent is something that you put, so my Spanish speakers, poner, you put it like outside, like if it's extra, it's extraterrestrial, it's an whatever. Okay. So an exponent is this little guy up here. And the exponent will tell you how many times a number is used as a factor. For example, if we have 4 squared, that's the same thing as 4 times 4. We're multiplying 4 2 times. 4 times 4, that's equal to 16. But another way to write it is 4 squared. By the way, we refer to this big number right here. We call that the base. So if you're all about that base, that's what that's referring to. That's what Megan Trainor was talking about right here. You can remember base means the big number. And the exponent is a little extra. It's just kind of hanging out right there. There, that's my hint. Right, so let's write each of these with a base and an exponent. So let's count how many we have. First, we know we're going to use 2. 2 is our base, so we're going to make 2 super big. There it is. And now we need to figure out how many 2's we have. This is 1, 2, 3, 4, 5, 6. We have 6 2's, so this is 2 to the 6th power. It's what happens when you multiply 2 times 2, which is 4, times 2, which is 8, times 2, times 2, times 2. It comes out to 64. Fun fact. So you can say 2 to the 6th power equals 64. But 2 to the 6th is just a shortcut way of saying 2 times 2 times 2 times 2 times 2 times 2. What this is not. This is not equal to 2 times 6. So please don't tell me, oh yeah, it's 12. No, it's not. That's not true. Actually, I want to cross that with a highlighter so that you can still see it. That is not true. 2 to the 6th is 64 because it's 2 times 2 times 2 times, etc. Let's do another one. Here, what are we multiplying? We're multiplying m. How many times are we multiplying m? 1, 2, 3, 4. 4 times. So this is m to the 4th power. And look at this guy. What are we multiplying? We're multiplying 9. How many times are we multiplying 9? Once. So it's 9 to the 1st power. So whenever you see a number by itself, you can be like, oh, there's a hidden little 1 in the exponent. Yeah. There you go. So you got bases, you got exponents. Okay, why is this helpful? Well, it helps you clean things up. So if you have a bunch of numbers together, you can group these factors, that is numbers being multiplied. You can group them all by the same base. So let's look at this guy right here. We've got 3 3s. Okay, so we've got 3 of those, and we've got 2 -7ths. So that means we can say this is the same thing as 3 to the 3rd power times -7. I don't know why I put that in 2, but anyway. I don't know why I made that negative, but -7 to the 2nd power. Because you count how many times it shows up. You have all these bases. You count how many times they're showing up, and you write that as an exponent. Please also notice the negative needs to stay inside the parentheses. It'll come in handy with PEMDAS later. Okay. So negative bases always need to go in parentheses, please and thank you. In fact, that's so important. I'm going to make sure you see it. Negative bases go in parentheses. Like this. Okay. Hey, look, I see a negative base coming up. Ta-da! Okay, here we've got -1. How many times do we have -1? I see it 4 times. I also see 6 twice. So we're going to rewrite this as -1 to the 4th power times 6 squared. You don't need the times between them. The times symbol between them, you can just straight up put them together like that. That's fine. If it helps you remember and you want to have the little timesy guy in there, that's great. Keep your timesy guy in there and you have a wonderful time. Now we're going to do exactly what we did, but backwards. Yeah. You can write it as a multiplication expression just so you remember what that means. First of all, what does this not mean? This is not 10 times 3, okay? This is not 30. What this is 1, 2, 3. Nice. We look at 3, we multiply that many times. 1, 2, 3. 10 times 10 times 10, which is 1,000. Fun fact, right? Okay, so we make sure we have it 1, 2, 3 times. Now let's look at b to the 5th. This means we're going to take b and we're going to multiply him. I'm going to write him out first. 1, 2, 3, 4, 5. Okay, so we have 1, 2, 3, 4, 5, but they're all multiplied together. B times B times B times B. Times B? Well, you get it, that thing. Cool? Cool. This is not 5 times B. No, that's not it. That makes me sad. Don't write that. Ooh, look at this guy. That's going to get super complicated. Well, okay, we have a 10. We have 10 once, so that's just 10. We also have x squared. That's x 2 times. So 1, 2. Go ahead, 1, 2. We also have y. We've got that y 4 times. So 1, 2, 3, 4. So we've got 1, 2, 3, 4 y's, and now we just multiply them all together. 10 times x times x times y times y times y times y. Nailed it. Cool. Well, something that's not cool, something that's very hot, is the sun. And the distance between the Earth and the sun is 10 to the 8th power kilometers. Okay, well, we've got 10 to the 8th power. Write this as a multiplication expression and then evaluate it. Oof, that means we are multiplying 10 times itself 8 times. So 10 times itself. 1, 2, 3, 4, 5, 6, 7, 8. Okay. 10 times 10. Watch this, guys. Times 10 times 10 times 10. Uh-oh. I'm going to run out of room. Times 10. Times 10 times 10 times 10. Was that enough? 5, 6, 7. That was one too many. Cool. What is that equal to? Well, I will do the math for you. That is equal to 1 followed by 10 zeros. And by 10 zeros, I mean 8 zeros. Yay! That's 100 million kilometers. This is a million right here. This is 100. Giving you 100 million kilometers. That's quite far. That's like the distance from the Earth to the sun about. Okay, cool. For our last activity, we are going to evaluate expressions. And how you evaluate an expression with an exponent is you take the number and you plug it in to this expression right here. So you start out, you've got 4 times m cubed, but this time m is 2. So now you just need to simplify it. But remember, we got to use PEMDAS. Okay, right? So PEMDAS tells us to use PEMDAS like that. So everything within grouping symbols can look like this if you want, but we often use these guys called parentheses. And then all powers from left to right. Remember, powers have exponents. And then multiplication and division. Oh man, it gave it away. Multiply and divide. Can I just abbreviate that? Too bad I did anyway. And then finally add and subtract. So add and subtract. Oops. Good enough. PEMDAS. Okay, cool. So let's start. Parentheses. Well, our parentheses are 2. So cool. Exponents. Ooh, we need to do these exponents first. So we're going to simplify this part right here. Okay, and what is that equal to? 2 cubed is the same thing as 2 times 2 times 2. Okay, so we're going to do that first. And 2 times 2 times 2 is 8. By the way, these are equal to each other. Equal. So 4 times 8 is 32. So that is equal to 32. Sweetums. Okay, now let's look at this guy. Except this guy has 2 things going on. He's got an X and he's got a Y. So let's plug them. That was weird. Let's plug them both in. We've got our Y here. We've got our X here. So we'll have 3 times whatever X is plus whatever Y is squared. So let's plug that in. X is -2. Y is -3. And now we need to do parentheses. Well, that's done first. Okay, PEMDAS. Exponents. Oh, we got an exponent right here. We need to do this exponent first. So that's the same thing as -3 times -3. Notice it's not -3 squared. It's -3 times itself, like that. Okay, now we do multiplication left to right. So 3 times negative 2 is 6. Negative 3 times negative 3 is a positive 9. Oh, guys, 3 times negative 2, negative 6. Ta-da! A negative 6 plus 9 equals 3. Kind of hard to believe this whole thing right here. 3. It's just 3. Okay, there you go. That's how to make your life more simple. Use PEMDAS. And remember, with your exponents, that the base is the big guy, the exponent is the extra, representing how many times you're multiplying that together. Have a great time on your homework.